There are four types of compounds that I'm going to cover in this lesson that contain the carbonyl group. The carbonyl group is this one right up here in its simplest form, a carbon double bonded to an oxygen. There are four types of molecules, ketones, aldehydes, esters, and carboxylic acids, that we're going to cover here that all contain that functional group, that carbonyl group. Down here at the bottom, printed sideways here, it tells us how we need to name these compounds. So I'll go through that quickly and then we'll do some examples. Ketones, the name ends with -one. The carbon in the carbonyl, that is this one that's double bonded to the oxygen, having the lowest possible number. So when you number the chain, you want to get to this carbonyl carbon as quickly as you can. Aldehydes have a hydrogen attached to the carbon in this carbonyl group. You can compare that to the ketones, where to the left and right of the carbon you don't have hydrogen. You have typically other carbons. When you're naming aldehydes, names end with -al, and the carbon in the carbonyl, that is the one that's shown here, by definition that's carbon number 1. You can see that the carbon chain either starts or ends with this carbon. In other words, it terminates right here, and whenever we name aldehydes, this carbon here has to be carbon number 1. If we move on to esters, again you see the carbonyl group, but in this case specifically, the carbon in that group is connected to not only this double bond with an oxygen, but then single bonded to another oxygen, and then more carbon chain continues, in this case to the right, and then there's also carbon chain to the left. When we name esters, the carbon in the carbonyl is carbon number 1 by definition. Whatever's attached to the O is named first, and then the name ends with O8. So when we name these, the stuff that is right here, I'm circling this region with my laser pointer, whatever's attached to the O is named first, and then we name the rest of this molecule off to the left here, with this carbon being carbon number 1. The last one is carboxylic acids, which you might be somewhat familiar with because you probably met acetic acid already. There's the carbonyl group, and there's an OH, a hydroxyl group, that is attached to the carbonyl. For carboxylic acids, you can see in the lower right, the names end with oic acid, and the carbon in that carbonyl group is by definition carbon number 1. So let's try this. 3-hexanone. We're going to draw 6 carbons in a row. This is a ketone, which means off of carbon number 3 we have our double bonded oxygen. This next molecule, hopefully you recognize this structure here as being that of an ester, and esters end in O8. Then whatever is attached to the oxygen, in other words, not the carbonyl part, but the other part that's attached to the oxygen, that's named first, and you can see here that that's a propyl group. So this is propyl, and then we name the rest of this 1, 2, 3 carbons propyl propanoate. The first propyl refers to what's connected to the oxygen, and then the propanoate is the 3 carbon chain that starts with carbon number 1 being the carbon in the carbonyl group. How about this next one? 3-phenyl butanal. Butanal is an aldehyde. We've got 4 carbons, and there's our aldehyde group. Then, off of carbon number 3, we need a phenyl group, and there you go. Now, sometimes this hydrogen, you can see I've actually drawn the hydrogen in, which is pretty rare. Sometimes that'll be left off, and we'll simply draw the molecule like that, and it's understood that there's a hydrogen hanging off in the lower right portion of this molecule. But let me put it back on here. There you go. So sometimes you draw it, sometimes you don't, it doesn't matter. but it's definitely there whether you draw it or not. How about this next one? This one looks like a ketone, and we know that because you have carbon on the left and carbon on the right. We're going to call this, how many carbons do we have here? 1, 2, 3, 4, 5, 6, 7. So this is going to be called 2-heptanone, and then we need to name the substituent groups 5,6-difluoro-2-heptanone. This one is an aldehyde. You notice the functional group for aldehydes right there. This, by definition, is carbon number 1. We're going to take the longest chain, which is 1, 2, 3, 4, 5 carbons. I'm expecting this to end with pentanal. And then off of carbon number 2, we have an ethyl group, so we say 2-ethylpentanal. This next one, 3-propyl hexanoic acid. The oic acid indicates a carboxylic acid, so let's draw hexanoic acid. Make sure we've got the right number of carbons there. 1, 2, 3, 4, 5, 6. Good. So that's the hexanoic acid part. We've taken care of that. Then, off of carbon number 3, we need a propyl group, and the carbon in the carbonyl is carbon number 1, so carbon number 3 is going to be this one right here, just like that. And it turns out in this molecule, which of these is the propyl group and which is the main chain, it doesn't matter. They're equivalent. If I want the main chain to go zip, 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 up, over and to the left, that's fine. Or if I want to consider just the zigzagging one that I've shown, the main chain, it doesn't make any difference. They're equivalent. How about this next one? There we go. What's that? That's an ester. So this is going to end in O8. We name whatever is hanging off this oxygen first, so that's a methyl group. Oh, so octanoate, right, of course, octanoate, because you count the number of carbons. 1, 2, 3, 4, 5, 6, 7, 8. Now we mention the methyl group hanging off the front, and now we just have to name this substituent. So we're going to say that one's a 2-methyl. So this is called methyl 2-methyl octanoate. How about one more? Butanoic acid. All right, well, that's carboxylic acid with 4 carbons in the chain. Good. This carbon in the carbonyl group is carbon number 1. Actually, this whole group is called the carboxyl group, but the carbonyl group is specifically this carbon double bonded to the oxygen. Carbon is number 1, so 4,4,4 trifluorobutanoic acid would look like that. This slide is simply a rehash of what we had at the start, except I've turned it sideways so that you could read how to name these in regular print orientation. And on the left you can see I've found models of these different molecules. We have ketones here where we have a carbon double bonded to an oxygen and then hands free to hang on to carbon up top and carbon below. An aldehyde is very similar. Carbon double bonded to an oxygen, but we have an H and then room for more carbons. Esters, I couldn't find a 3-dimensional model of an ester, so this one will have to do. The rest of the molecule and the rest of the molecule. And then in the lower left, a model of a carboxylic acid. You've got a carbon double bonded to an oxygen, that's the carbonyl group, and then OH, and then room for more molecule.